Hello, friends. Today on the notebook, we'll talk about systems of equations. And what I mean by systems is simply more than one equation. We're looking for where do these equations have the same solution? So when I put in an x, let's say I put in 3, if I got 7 back for all of the equations, then the solution to that system would be 3, 7. So if we're looking at a graph, we're looking at what points do they share, right? So if they ask how many solutions does this system have, let's say they give you something like x6 plus some stuff equals y, and x3 plus some stuff equals y. See, it's important how I didn't put all that stuff. We're not looking at the stuff. We're looking for the degree. Since the degree is 6 for the first one and 3 for the second equation, 6 is going to be the overall max number of intersections. So you can look at that. If we look at, let's go ahead here and pull up just a regular old y equals x squared. Well, sort of. We're going to have to come to the point 0, 0. So this is y equals x squared. And we're just going to cross that with some kind of line. Pick any line, right? But if we pick this line, there's two solutions, right? We can visually see two solutions. Oh, I'm cutting ahead here. If I put the line down here, however, there's no places it intersects. Therefore, these two lines have no solution. There's no intersection on these. So it's the points they intersect. It's where they have the same solution. So back up to here for our example. When we have x6 and x3, the most places it's going to cross is 6, unless it was the same line. So if somehow we could reduce this line to being this line, then there would be infinity solutions, but that's not the case here. So it's going to have 6 or 5, 4, 3, 2, 1. So basically, at most, it'll have 6 intersections. This last one here, we'll get into this last one when we look at the graphs. So let's go ahead and look at the 4 ways to solve systems of equations. So we have, just look at the equation, simple just glancing. You graph the lines and see where they touch. You substitute, you find some kind of clue, and you move things around until you can actually get some algebra in there and get to a solution. And then if all else fails and you don't see a way to do the other 3, we can try elimination, right? And so I'll tell you how to recognize when to do each one. So on the quick analysis, there are 2 occasions where you can look, and it's on the right hand side here, but we're actually going to start over here with 0 solutions. 0 solutions, those lines are parallel because they never touch. And if you look right here below, see parallel lines, if the solution is where they touch, those lines are never going to touch. So if the slopes are the same, the lines are parallel. And if they're parallel, they never touch. And so we're looking to see, do they have the same slope? Now the difference between 0 and infinity lies right here. If they don't have the same intercept, then they're parallel, they're never going to touch. Here we just have to see if we can figure out a way to turn these into the exact same equation. And if I multiply the top equation times 5, it turns into the bottom equation, right? If I take the top equation times 5, it's going to turn into 20, 5x, and 50. So that's how I know they're the same line, because they're just different versions of the same line. And when I say same line, it's in quotes, because clearly this is one line and row 2 is a different line. So clearly they're 2 different lines. But what I mean by same line is they have the same equation. They're going to occupy the same space on the graph, right? So the very first way that we can tell on systems of equations, and that's the first thing you're going to want to check, look for the same slope. If they have different intercepts, there's no solution. This one, you might not be able to tell they have the same slope, so don't look for the same slope. Look for multiples of the same line. Look for ways to turn them into each other. If we did the work, we could divide this and we could work things out, and we could see that they're both lines. I would need a y here, so I forgot my y. But if we did the work here, we would see that they both turn into y equals x over 4 plus 3/4 And this one would also be, because we would divide by 20, divide by 20, divide by 20, y, and then that's 1/4, and that's 50 divided by 20, 3/4. They are the same line, in fact, if we did solve for that. But don't solve for it, just look and see if they're multiples of each other. So if they're multiples of each other, they're the same line, because that's how we reduce. We know we can reduce and make lines easier to work with by multiplying or dividing across all the terms. So they're going to be, if you're multiplying by the same thing, then it's clearly the same quote unquote line, right? Same with the slopes. If the slopes are both 5, that's not in quotes because 5 is a number. So the slope is 5, the other slope is 5. Those are the same number. It's kind of interesting to look at it that way, but that'll come across in geometry, that distinction. So we're here now in graph the lines, and when we graph the lines, we are looking for a point of intersection, as I've probably alluded to. So here, these are counting by 5s, so that's going to be -10 for the x's and -5. Right, we're going down one box and over two boxes, right? And it's going 5, 10, 15, 20, right? So the point of intersection is -10, 5. And this is an important point. The reason we want to find the solution, this visualizes pretty well what we're looking for. At this point, let's say this models a basketball player and his talent, and this blue line models a basketball player and their talent. And this is a temperature, right? So out here, the blue player is doing much better. So if it's -20 outside, the blue player is going to be a better player. But if it's -5 or warmer, it actually is going to be the red player I would invest in if it's going to be warm weather. So see, if it's going to be cold weather, I would invest in the blue player. But at this point, anything -5 or more, so this is, or -10 or more, this is the turning point. So this point right here, this is the point where one model overtakes another model. And so that's one reason we want to look at it. Another reason, if you look up here, one important point of intersection is when we have just one line, but we set that line to 0. So how many humps? 1, 2, 3. Ooh, buddy. So I know I'm an x4. So we set the whole thing to 0. There's no y, it's a 0. They want to know the points of intersection. So again, this at most would have 4. We're setting it to 0. And so these are the 4 points of intersection. So if we set it to 0, we're looking to solve a system where y equals 0 and our line. An aside, it's not really how it's done, but points of intersection are just super important. And so this particular is, they'll give you a line and you just imagine that line as a system. You can graph it and right, you can just look at the points. And so that's what you're doing here. You're just looking at the point. When it's the same line, in quotes, because the blue line is clearly not the same, but the red line times, what is it, 4? That's how we got to the blue line, times 4 on all the terms, right? Once we got to the blue line, we have the same thing. So we could divide by 4 to see that they had y equals 3x plus 5. They're the same line, same slope, same intercept. But you can graph it so I would just look at it. I would have done method 1. I would just look at the equation. But if they graph it for you, well, and clearly that's infinity, right? So I wouldn't bother graphing this if they gave me these two equations, because I could see I'm multiplying times 4. Same with this one. I wouldn't graph it. I would just see I've got the same slope but different intercepts. So this one's starting at 0, this one's starting at 3, but they have the same angle, 1. That's 45 degrees actually. So they have that same angle. So they're never going to touch. They're parallel. They have no solutions, while these lines always touch. They are each other. They live in each other. The last two ways you're working on this, you're going to use algebra. So the first two ways, you're just going to glance. You should be done with those in less than 5 seconds. So if you're not able to do the first 2 lines and just look at it and say, I'm 100% certain I can get this like that, go back and review with more practice problems, because when you take the test, they give you a certain amount of time and they're mixing the problems up. So while I said you can use any way you want, the first 2 ways are the ways that are going to take the least amount of time, and the SAT people are not going to want you to use these next 2 methods when you could just look at it. But keeping in mind, just like the quadratic formula always works for that, you can do elimination, you can do substitution, you can do the algebra. So let's look at a case where we have to. I don't want to graph these two lines. I don't want to divide by 3, move things to the other side. I don't feel like making this a y equals mx plus b. This one would be easy to graph, but I don't want to graph the first one. So my first clue is I don't want to graph and I can't tell nothing. I don't want to convert too many fractions. So I am looking at x goes by this name and x also goes by this name. So having it as x isn't very helpful because I've got an x and a y and that's two variables. But if I use this name for x, so let's use this name for x. If I use that, then it becomes one equation, one letter. And that's just pretty much the end of pre-algebra, the beginning of algebra. This is the nice, straightforward equation. So the first thing I'm going to do is I need to have no parentheses, or I could divide by -2 everywhere, which, do you want to do that? I don't want to do that. It would have gotten rid of the -2, but it would have created a whole bunch of mess, and I don't want to do it. So what I'm going to do is I'm going to distribute this -2 here and this -2 here. And that's kind of why I put parentheses where the x is. You're going to substitute all of this into x. So this 2 has to go on everything. So it's -2 times +3, one of each. Opposites do not like each other. And 2 and 3 is 6, and that y is just times y. And then -2, +4, one of each. They don't like each other. And we are working with -8. And then this 3, so we just leave it. So the next thing that we're going to do is we're going to see if we can simplify in any way. So we have some constants here, and we can combine those. So we have a -8 and a +3. So who wins? The negatives. How much do they win? By 5. So I like to think of these as two teams that are playing against each other. And one has -8, goes against +3. You're going to run out of positives, and you're going to only have negatives. They dominate, right? And so -5 is what I'm left with on the constants. I don't have any y's on this side. So that's as far as we can go on this side. So now what we want to do is move everything, right? So I'm moving the y's to one side. This is -6, so I could add 6, and negative and positive, that would cancel. If I wanted to divide and get rid of that 6, and leave the y by itself, I would have to do that, and I don't want to do that. So we're leaving that 6 with the y. We're leaving them together as minus stuff. So we're going to add stuff and add stuff. And we already had a 1y. So that's 7y. Plus minus stuff is cancels, and we still got that -5. And so here we can just divide by 7 to separate it now because it's not so hard to divide on all the terms. There's only 2. And so that's 1 times y, which is just y, and -5/7 is what we get. Now, we could have chosen to substitute the other thing back in. So we could have chosen this version of y to replace this, and we would have solved the same way. Instead, what I want to do is I've been given this y, so why don't I just put that right there? And so now it becomes a number, and now I'm good to go there. So now I just have 1x equals some stuff. So let's convert that stuff. So -5 times 3, on top we've got -50, and there's 7 on the bottom. So we're really multiplying 3 over 1. So really what this problem is 3 over 1 times -5 over 7. And that's just straight across. Remember, multiplying fractions is straight across. So that's -15 and 7, if you don't know. Multiplying numerator, divide denominator. And then this 4, I don't like that version of 4. What I like is this version of 4. And the reason is because that version of 4 gives me a common denominator, which then says -15 of something plus 28 of something means the positives win by 13. And then the thing is 7. So that is my x, 13/7. And then I'll write my solution like this in the form of xy. So another form of substitution is this plays on the fact that if this equals y and this equals y, then everything equals y. So they must equal each other since they both equal the same thing. These can't be two different y's in the same problem. You can't name things different. It has to be this y. if it had a 1 or 2, but then that's a particular y, and no, we're not dealing with that. So these are the same y. And so we have two equations that also equal y. They must equal each other. That's called the transitive property of equality. So on the transitive property of equality, we can set these two things equal to each other, because if one thing equals one thing and the other thing equals one thing, then they both equal one thing, they both equal each other, right? We could also say equals y, right? All three of these things are created equal. And then I just don't need this part here. For now, we'll take this out. So now this becomes another one of those straightforward pre-algebra, algebra ones, where we're just going to get all the letters on one side, the numbers on the other. So we're going to subtract 4 from both sides, and we're going to add, I don't want to break apart this 2, right? So let's look at what would happen. If I wanted to break apart this 2, I would have to go on. Oh, I'm not ready to break apart that 2. We're going to leave 2 with her, with x. That's a bit much. So we're going to leave that together. So I'm going to start with moving this to the other side first. And when I say move to the other side, I really mean cancel out with the opposite. So we have plus 3 minus 4. So the winner is minuses. They win by 1. And then I'm going to add stuff because I was subtracting stuff. And I just have to do it to both sides. So that's 3x. And now I can divide by 3 because I only have 2 terms. It's not so bad. So 3 divided by 3 is 1. That's why I did that. 1 times x. And then that's my answer. So then what I can do is I can take this 1/3 and I can put it right here. And one thing I'd like you to see, we have y equals something like this. I want you to go back to 2nd grade. I really want you to go back to thinking when you were really little and you were doing fractions. You have 4 whole fractions, and you want to take away 1/3, right? It's a plus 4 and a minus 1/3. So these are going to be fine, right? I just want to take away 1 of the thirds. So that leaves me with 2 of the thirds. And I still get to keep these. I'm only breaking apart 1. I guess I'm just going to get rid of this 1 slice here, which went there. So how much am I left with? 2/3. So, okay, make sure, don't get lost in how mumble jumble everything is. These are basic numbers you have been using your whole entire life. These are little kid numbers. Just go one step at a time. So the last method you're going to try, if you've tried all the other ones, is going to be elimination. And your clue for elimination is you have x and y on the same side, and then you have the constants on the other side. That's called standard form. And if it's in standard form, that probably means they want you to do elimination as your method. Now, they could be tricking you. Maybe they want you, like you look down here, maybe they want you to solve here. If they both looked something like this, like we had a 2x plus y equals 4, I would move that y over here, and then I would move the 3 over there. And when I say move, I mean do the opposite. And so that would give me these two equations, and then I would set them equal to each other once I solved for y by moving this 2x over here. So I have 4 minus 2x and 3x minus 3. They both equal y. For elimination, as the goal says, we want to eliminate. We either want to eliminate an x or we want to eliminate a y. So for this example, let's eliminate x. And what I mean by eliminate x is I want to get this and this to have the same number. Well, how would I get them to have the same number? I could divide the top by 3, which I'm sure you already know where this is going. I don't want to do that. Okay. I could multiply the bottom times 3. And then I will end up with the same number. So let's do times 3 times 3 times 3. And that's going to give me 9x minus 12y equals 9. And the reason we did that is now we can combine these into a line. Combine means add or subtract. Okay. I'm going to choose subtract, because when I subtract, 9x minus 9x is 0. 2 minus 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 just means plus. So minus minus is a plus. 1 of each is a minus. That's multiplying 2. So since I saw 2 minuses, I know that turns into a plus. So that's 14. And then this 7. All right. So my equation that I have is 14y equals 7, because this is 0x. I'm not going to write 0 times x. And that's super easy. Y is 1/2. Divide by 14 on both sides, and we get 1/2. So if I did choose a different route, I would leave this one the same, but try to get this to match. So we'd be multiplying times 2. So that's 18x plus 4y equals 32. Okay. I don't want to subtract when I combine them. Here I subtracted because I had 2 9s and I wanted to subtract. But here I have a positive and a negative, so I'm going to combine them by adding. You can add or subtract. I'm going to add because when I add them, this is 20, whoa, x, this is 0y, which is what I wanted, and this is 35. So then we end up with x equals 35 over 21. If we divide by 7 over 7, which is just 1, 35 divided by 7 is 5. 21 divided by 7 is 3. X equals 5/3. So I could have eliminated them by making these two numbers the same, or I could have eliminated by making these two numbers the same. Either way, you just want to make the two numbers the same to zero something out. One thing I could have done, because I found out that this was 1/2, I could have taken that 1/2 and substituted that back in right here and just put a 1/2 right there for y. So that's what we'll do. Put a 1/2 here. So this is essentially saying 2 times 1/2, and then you just go straight across. 2 over 2. But you should pretty much know these are multiply. They go on the top 2, and the bottom is divide 2. So that's just 1. And then we leave this alone. We can't do anything with it yet. So then we're going to move the numbers. And again, I could move the 9, but I would, if I'm dividing or multiplying, I got to do it on everything. And no, thank you. Those aren't pretty. So what I'm going to do is I'm going to subtract the 1. Now I can just divide by 9 on both sides. And that's 1x, and that's 15 over 9, which we can divide by 3 over 3, which is just 1. Just a fancy one, but that makes that 5/3. So x was 5/3 even if I did elimination or if I did substitution. So either way, eliminating, you're just going to say I either want these two to be the same or I want those two to be the same, and then I'm going to add them together to create a brand new equation with just one letter. All right. So let's look at that elimination one more time, but here is just a special way to write it. Okay. There's really nothing about this that's different than what we just did up there. We're going to look and see that we have standard form, and maybe this is a nice one that I could maybe convert this into possibly into standard form, or into slope intercept rather. It is in standard. But this one would be messy and I'd have fractions because to get this y by itself, I'd need to divide by 3. And 13/3 is not a number I want to mess with. I don't know about y'all. So let's go ahead and see how we would do this. So we're just bookkeeping. So I'm just rewriting it into something that's nice and easy for me to keep track. So if you can see the pattern, fantastic. Go you, math might be your thing. So I'm just rewriting row 1 with just the coefficients, 2, positive 3, 13. And I'm writing row 2 with just the coefficients, 3, negative 1, 3. So we can think of this as x, this is y, and this is equals, and this is my constant, right? So that's how I'm keeping that. Now I can easily look at this and say, what do I want to zero out? So I could technically multiply the top times 3 and the bottom times 2. If I did that, that would give me a 6, a 6, a 39, and a 6, a negative 2, and a 6. Okay? So that's one option. So you don't have to just only multiply one row. You could multiply both rows to give them both a 6. I multiplied this one by 3 and this one by 2, and look, switch them around. I could also, if I wanted to, which I don't, but I could multiply, 2, 3, 13, 3, negative 1, 3. I could multiply them negative 1 and 3, switching these two, which would then turn this to a negative 3 and this to a negative 3. Then they'd be the same number, because that's the goal. We wanted them to be either these ones to be the same number or these ones to be the same number. Okay. When I'm looking here, I'm like, okay, I think multiplying the bottom by 3 is my best bet. So I'm going to leave row 1 alone, but I'm going to multiply row 2 times 3. That's 9, negative 3, and 9. And now I can just put my little equal sign here. What do I want to do? Add or subtract? Well, how am I going to zero these out? Add. So 2 plus 9, that's 11. Oopsie, I did it again. Brittany, 11. This 3 minus 3 zeroes out, so my y's are zeroed out, and this column was x's, remember, so that's 11x. And these ones are my constants. 13 plus 9 is 22. And so we can see 11 times 2 is 22. So x is 2. So now we can take this 2 and we can substitute it into our equation here. And x is 2, so 2 times 2. So instead of x, I'm going to put 2. And I didn't really need parentheses, but I like it. And then 3y equals 13. So now we have a new equation that we can solve for. All right, and I'm going to clean this up. So that's 4, 3y, 13, and we can subtract 4 from both sides, which gives me 9. And then 3y, divide by 3, divide by 3, y equals 3. So the matrix, you don't have to use it, but if you do, it puts all the numbers in nice little rows. Just remember that this is your x's, this is your y's, and this is your constants. So all 4 ways will work. All 4. You can look at the equation, you can graph, you can substitute, you can use elimination. However, if you look at this bottom one, I don't know about you, but I can't look at it and tell. And I don't want to graph it, right? So I can. Just because I can doesn't mean I want to. So I don't want to graph. I'm looking at it. I'm going to have to do a lot of manipulation that I don't want to do to get to y equals mx plus b. So what I'm going to do instead is see I am set up for elimination. All the x's are on this side, all the y's. All the x's, all the y's. And then you put the numbers on the other side. That kind of, okay, want me to do the elimination. And remember, what we're eliminating is we're trying to find out a way, some kind of multiplier, okay? Kind of multiplier where I can make these two numbers the same. I'm allowed to multiply by anything, I just have to remember to do it here. Okay. I want to make these two numbers the same. So that's what I did. I made those two numbers the same by multiplying the bottom by 3. Then I can easily just subtract them from each other, right? So that is elimination. Hi friends, click the link in the description for all of the worksheets that go along with today's video, and if you want to go through the notebook from the beginning or dive into another topic, check out the other videos on the channel. And of course, it wouldn't be a YouTube video without the obligatory begging, so I put a lot of effort and time into this. I just want you to get something that's not a random AI generated, blurb of nonsense. I really want people to learn, and so I can continue to do that if you can continue to support me, and so I would love a like or a subscribe, anything that helps the algorithm, and if something clicked or if something confused you, or if you want to dig into something I haven't covered yet, say so in the comments. Thanks for watching, and we'll see you on the next page of the notebook.